G'day guys and welcome back to the channel. So in today's video we are going to be talking about Toyota's crawl control, specifically the turn assist function. Toyota have developed this to turn this large four-wheel drive around in a tight radius using onboard technology. So today we're going to be testing it out in different track and road conditions to see whether it's actually worth using in real world scenarios. So stay tuned and let's get into it. So before we get straight into testing out the system today, we need to understand how the system works and why Toyota have designed it. So I do have a full video on the traction control system and crawl control system of this Landcruiser 200 series and how to use it. So check that out if it's something you're interested in. But in brief, the turn assist function is the vehicle's way of controlling the ABS system to apply extra braking force to the inside turning rear wheel of the vehicle in order to attempt to pull the vehicle around. As the vehicle turns either left or right, it doesn't matter, extra braking force is applied to that rear wheel, which will then put resistance on the surface you're driving on. This will have the effect of physically trying to pull the vehicle around in conjunction with the driver putting in a left or right steering input. So today we're going to be testing it out on varying terrains from road, gravel, loose rock and sand. We're going to see whether or not the traction surface makes much of a difference to the results and see whether or not it's actually a viable system to use when you're off-road and out on the tracks. So let's get straight into the first test today. Okay guys, so the first test we're going to do today is on this tarmac car park here. We're going to do two tests. We're going to do one with the vehicle just driving as you would normally with the open differentials. We're going to do a 180-degree spin. We're going to measure the widest point, which is going to be the outside front turning wheel. We're going to put a cone down on the widest point on that 180-degree turn. We're then going to do it again, activating that turn assist function, and just to see whether or not that turning radius is tightened on this high traction surface. We're going to measure the difference and then we're going to see how much of a difference that system makes. So let's get straight into it. So like I mentioned, we're going to be testing the turn assist function on varying traction surfaces. We're going to start the testing on the highest possible traction surface, moving all the way down to the lowest traction surfaces. We're going to conduct two tests on each surface, measuring the differences between the turning radius. Okay, so being an electronic system, there are some steps you have to put in place in order to activate the turn control system. So the first one is you need to make sure your vehicle is in low range four-wheel drive. So to do that, place the car into neutral, turn this knob here to low range. You'll hear it engage and the dash will then change display. Putting the vehicle into gear and then pressing the crawl control function, and that again will tell the display to show the crawl control is activated. Once the crawl control is activated, it's just a matter of pressing the turn assist function, and then again another light will show up showing you that that is activated. We then turn the wheel to full lock in the direction we wish to travel, handbrake off, and then let go of the pedals. Now I should note, the turn assist function is not designed, nor is it recommended for use on a road surface like demonstrated here. This function puts extra braking forces on the inside rear wheel, and on a surface like this places huge amounts of stress on the vehicle's drivetrain and suspension components. This was only done in this video as a baseline test for a high traction surface. So there we have it guys, there's our baseline test for the high traction surface. There wasn't much of a difference there in that turning radius. What we're going to do now is we're going to measure how wide that outside line is on that turning radius and see whether or not the turn assist made much of a difference. Okay, so we can see here the difference in that test. We've got the red cone here, which is the widest point of the first test we did with no electronic systems on. So the outside wheel came out to 11.38 meters wide in that first turning circle. The second test here, the rear of the wheel was on the inside of this green cone here, and we got a total of 10.6 meters in that turning radius. So we have got a bit of a difference, but not too much on that high traction surface. So let's move on to our next surface and see how we go. Here we are at the next test now. So the next surface we're going to be testing the turn assist function on is gravel. So gravel is generally made up of a lot of loose rocks and dirt. It's fairly small in size on top of a fairly hard packed surface. So we're going to see today exactly what the turn assist function can do for us on gravel. Let's go. Like our previous test, we start out with our standard full lock turn without any electronic assistance. One thing to note is that sometimes the turning radius can be slightly larger on a lower traction surface, just due to the limited traction at the front wheels and the potential for low speed understeer. Moving on to the turn assist activation, we can see that the lowered traction surfaces allows the rear wheel to physically lock up and provide a greater chance for the vehicle to be physically pulled around by the rear axle. From the drone camera, we can clearly see the advantage the system has on the vehicle's turning radius. As the vehicle is completing the turn, we can see that the bull bar of the vehicle is significantly closer to that white patch of dirt when turning without the turn assist. Okay, so our tests are complete, our cones are out. Let's again measure up and see what sort of advantage we've got through that turn assist function. Just as before, the results are in. So the outside rear wheel here is 11.4 meters from the starting point, and the outside of the rear wheel here with the turn assist on is only 10.2 meters. So although we've got a 2 centimeter wider radius with the system off, we've got an increased benefit there from a turn assist on this gravel. So we've got a win here. Let's move on to the next test. So the third test today is going to be on loose rock. So we're here at a relatively flat area and we've got rock varying from a couple of centimeters to some rocks that are bigger than sort of the fist and a hand. So we're going to see how we go today. Theoretically, this turn assist function should do fairly well here. These loose rocks should sort of dig in a little bit on that inside rear braking wheel, and it should provide a little bit more resistance on that wheel, therefore helping the vehicle turn around. So let's get straight into it and see how we go. Again, as with the gravel test, the potential for small amounts of understeer in normal driving conditions is to be expected when on a loose traction surface. The turn assist function, like the gravel test, allows the rear wheel to physically lock up and drag the vehicle around during the turn. So the third test on loose rock is completed. Let's go measure up and see how we did. So here we have the results from the loose rock test. We've got the outside wheel with no turn assist function on at 11.35 meters. We've got the outside wheel with the turn assist function on at 10.44 meters. So no significant change in relation to our other tests. Let's go and see our final test on sand. Okay guys, so the fourth and final test today is going to be on sand. Now theoretically this should provide one of the best results. Again, same with the loose rock, that inside rear wheel should provide the resistance to dig in a little bit and really give the car the maximum opportunity to be pulled around by the rear axle. So we'll line up our cones and get started into this final test. Now it should be noted that this is not particularly boggy sand due to recent rain. However, it will still represent how the system works and provide an accurate result for comparison. As you could imagine, if this was conducted in significantly deeper and softer sand, we would expect the results to show a significant advantage. Boggy, deep sand would allow the rear wheel to lock, bog down and provide a strong resistance to assist the wheel in tightening that turning radius. Okay guys, so like before, we have our results for our final test. So the outside wheel without the assist on is at 11.5 meters, and our test with the turn assist function turned on is at 10.2 meters. So decent savings there. So let's jump on inside the car and we'll go through some of the results we've got from today's testing. Okay guys, so I've collated all the results from the 4 tests today, and we've got the percentage change for each of the different traction surfaces. So we'll start with the road test. So the initial turn was 11.38 on its outer dimension, and when we turned that turn assist function on, we went down to 10.6. Now that provided a percentage decrease of 6.8% in that wide radius that we've got there, that turning radius. So we're not expecting a huge result from a tarmac surface. It's very, very high in traction, therefore the rear inside turning wheel did struggle to lock up and really pull that car around. Moving on to gravel, which was our second test, we had our outer dimension for our normal driving at 11.4 meters, and then we had 10.2 meters with the turn assist on. So that provided a decrease of 10.5% in relation to that radius being reduced. So that was quite a decent change there. We did notice that it was a little bit wider on the initial turn there, and that's probably due to the fact that the gravel has less traction, and therefore even without the turn assist function on the front wheels are probably slipping just that little bit, increasing the overall radius. Moving on to those loose rock tests that we did, we had 11.35 as our outer radius for normal driving, down to 10.44, and that provided a decrease of 8%. So not quite as much there as the gravel, however it's still an 8% decrease, which is still a positive. And moving on to sand. Now I have to note that this is not very boggy sand that we're doing the test on today. However, it's all we've really got access to for this test. So we started off there at 11.5 in the outer dimensions for normal driving, and down to 10.2. So again, we had our widest radius turn there without the turn assist function on, and that's again due to the reduced traction. The front wheels would have been slipping or understeering just that little bit as we turned around, just on that loose surface. However, we did see the biggest percentage change in relation to the reduction of that turning radius, down by 11.3%. Now this is down to the fact that inside turning braking wheel can stop or brake heavily and provide quite a lot of resistance on the surface we're driving, as it does dig down and into the sand. So I'd say that overall, if we were to find some very boggy sand, we're going to find some increased results from that again. However, we do notice that overall this system has provided quite a decent benefit. So guys, there we have it. That is the turn assist function in the Toyota Landcruiser. Now look, obviously in all of our tests today, we have seen a reduction from whether it be 6% all the way up to 11%. There has been a reduction in that turning radius. So we can say here, the turn assist function works correctly. It works like it should and as it's designed. But the real question is whether or not you would actually use this in a real life scenario, and whether it's something that comes to mind or whether it's something worth setting up when you are out on the tracks. Now for me personally, I've been forward driving in this Landcruiser for over a year now, and it's not something that I've ever used on the tracks in a real world scenario. Seeing the results today though, it does give me some confidence that if we do need to do a tight radius turn, that it is going to reduce that turning circle a little bit. However, probably the biggest benefit we're going to get here is from sand. We can see if we are on a boggy beach or whether we're on a dune system, we can use that turn assist function to do a nice tight turn, and it might help us get around some trees, avoid us getting close to water at the beach, or maybe on the edge of a tall sand dune. So there are some benefits there, and it's definitely going to help, albeit it's a little bit minor, but it is definitely provided some positive results today. So I hope you've enjoyed today's video. I hope you've learned a little bit from the video today. And look, if you have any questions in relation to any of the topics we've spoken about today, or the testing that we've done today, make sure to send us a message on Facebook or Instagram at Exploring Oz, and we'll be sure to get back to you. Otherwise, guys, take it easy, and we'll see you in the next video. Cheers.